right, so now let's do more about lists. Oh, one thing that, I mean, the list has a lot of functions. If they are numbers, sometimes it characters too. You can get the minimum, the maximum out of the list. You can again, the shortcut is do the sum as the built-in function to sum multiple values from there. Like the data is really 1, 2, 3. If I do like sum of data, and then you get the total sum out of that, right? It's pretty neat, right? It does automatically. So again, have a lot of shortcuts there. If you want to get the maximum out of that, you can say max of data, and it will print the max out, which is 3. The minimum, again, will be just 1. So if you want to do like a max of, let's say, letters, as long as it's say cat, and then dog. See, dog is the maximum. The minimum will be, what do you think, cat or A?
I think A.
Okay. Oh, let's do that. Same rules, right? ASCII values. So yeah, that's pretty good. Pretty cool stuff. And I have the sorting functions. You get that already. The length we say. Okay, so now printing data out using two-dimensional arrays or two-dimensional list. When you print two-dimensionals, in this example here, would be a little bit be really careful, because if I were to, let's just say, remove that, it would print not data but numbers, right? The length of numbers, again, if you put length of numbers, you actually get into rows only. So row 0, row 1, row 2. And if you print not data but numbers at row I, which is 0, you're going to get those each individual list in this example, because I'm only referencing the first from the list, the element in that list called 0. So if you to print that out, you're going to get each list, right? Each element is a list. If you want to print the actual element in that list of row 1, you have to use its second index. The second index is referenced by another bracket here. Okay, so that is a two-dimensional list. The first bracket is the first index, represents the row. The second is the column. Okay, so if I'm going to print all the first column items, I put 0 here. So now it's going to print just the first column data, because 0 is fixed. I did not change, it's not dynamic, so it's always 0. Row 0, column 0. Row 1, column 0. Row 2, column 0. I'm going to get 147. So I get 147 out of that table. If you want to print every column in each row, well, then this has to be dynamic. So we call it J. So that means for each row I have to do an internal loop again. So you can say here for J, in the range of the length of numbers of I, right? Because, so this way, if you do it this way, it'll work for any size, whether it's a rectangle or not, because I will always give you the range, right? Dynamically, automatically. If I say, well, the length is, the column is 4, if you put 4 here, it'll work. Because from 0, 1, 2, 3, which is 4 columns, yeah, it'll work. As you can see, it prints, oh, I'm missing one colon here. It's going to print everything from that table for me. Yeah, I have the full table printed out, but it's not the way I want it because I put the print here. So I want to print something that it looks like this, without the commas and the square brackets. So this is a formatting issue, right? I want to print row by row. So that means, remember we did this last element here called the end, right? Don't put, you have to put a space, an extra space for each number. So for each row, the row of I, yeah, for each row, for each element in the row of I, I'll put the J element out, which is the J element out. I'll do that internal loop. This internal loop here will loop through every column in that row first. So it prints 1, 2, 3, 10. I'm finished. I'm going to go back out to the outer loop. When you back out, then you want to back out to the outer loop here, and I want to print a statement so that it moves the character return and then the line, the cursor to the next line. Okay. If you don't provide that one here, then you're just going to have a string of text, of numbers, right? Because I removed the character return, the line feed. But if you say, okay, I'll print each row, after the row, then move to the next row and then print again. So that's why you put that extra print statement in there to print that character return and the line feed. So now, when you print it, it prints nicely in that output. Okay. And I put a single space. You can put a dash, put a comma, whatever it is. It'll be assigned to this end parameter here. So as you can see, it prints nicely because I have 4 columns exactly. And I mentioned earlier that this is not a good idea. Okay. Even if I just say, oh, it's a rectangular, so I'm going to say the length of the numbers at column 0. Because that would give me 4 also. But this is a fixed value. If it's a perfect rectangular, yeah, it'll work. Right? No problem there. It'll fail when I remove one of these rows, columns. Okay. It should fail. You see that it's out of index, out of range. Because I'm expecting 4, but when I get to this point here, hey, where's the 4th one? Right? It always references the first row only. So that's why if you put the O0 here instead of 0, you put I. That means for row 0, get its maximum range. Put it there. So I'm going to go from 0 to that range. For the third row, I have only 3 elements, so from 0 to 3. Okay. So it's always safe. In this case, it doesn't matter what the size is. It will print it out without error. So be really careful about that as well. And that's why these variables become really, really important. One change can either save or break your code. Okay. And when you write code, you always want to write it very defensively. Okay. So there's times that you say code defensively. Make sure everything works. And think about not just the now moment, but the future moment as well. Okay. Cases. What if this is an empty list? Right? It'll still work. It won't print that row because there's nothing there to print. It will still work. It won't fail. So your code must and should work in every case. So all possible cases. And usually if you work for a tech company, when they interview you, they'll ask you to test all these we call edge cases, right? When the list is 0, when the list is maximized, when the list has some irregular values in size, right? You have to test all those, make sure they work. What if the list has only 1 element? One has, n elements. It should work in all cases. Okay. And they will ask you, and you should know, right? As a coder, you should know those. Okay, so this is very, very common algorithm when you loop through a 2-dimensional list or through a table. So then now I have access to every element in this table here at this point, because I loop through every column for every row, and then I can check inside every number, see if it matches a certain value. So kind of similar to the homework assignment. Okay, so my theater seating here. If I pick, the price of 3 or the price of $6, well, I have to look in this list here how many I have $6 in here. So I will find the first slot open that is $6 and I change that to something else. Right, so let's just say that I'm going to look for 6. So how do I know it's 6 or not? Well, once I loop through that list, I need to check that current value. So in the first case would be the number 1. Then I'll say if the numbers of I, j, if that equals 6, if that's the case, then I want to change its value to something else. So I can say numbers of I at j is going to be 0. Otherwise, check the next one. And if that's the first case, if you're replacing that price, then usually we're done. So you can cause the break to exit out of that. So you don't replace all the 6s with 0s, right? Each one slot has the value there and 0. So right now, if I run this and we'll print the numbers at the very end outside the loop here to really show that numbers at that position really did change to a 0 instead of a 6. So the 6, the first occurrence it finds, it's going to replace that with 0, and then it will just exit out. So I'm going to print the numbers before and the numbers after. Okay, I'm not going to print this one here. Because I'm just basically processing, right? I'm replacing the first number I find that's equal to 6. Replace the same slot, same position with 0. And we'll see if this one works. Okay, so we'll run it. And well, did it work? If number equals 6, I didn't see that work. Maybe I didn't have that thing here. Let's clear this. Let's clear the list first. Let's try again. What's going on?
You have it checking the value equal to 0, not setting the value equal to 0. Double equals.
Cool. Good catch. But there's no syntax, yeah, no syntax errors. So yeah, careful there. All right, let's try again. So now we replace that with 0. And so next time you look again, the second time around, you replace another ticket there, and you check it. Okay, if that's 6 has been replaced, then there's no more seating for 6. Sorry, all the seats are taken. Right? Choose a different value, a different price. But while you're doing that, though, it has to be occurring within the loop. Okay? Otherwise, if you stop and do it again, then all the data gets refreshed again. It's already set again. Okay? So it should be occurring when you run the program and until I press Q something to quit. Right? So you can manipulate the data live at that instance. Okay, so then if I want to say, so one of the questions in the assignment is to ask you to, if I pick a seat number, and let's just say this one will look like that. It looks nicer that way. No, it doesn't really matter. But pick a seat number and assign the number if that seat's not already taken. So again, if I were to say this seat here is taken, so if it's taken, you put 0 there, right? So 0 means it's taken. So I want the seat number here. What seat number is that? I mean, just 2B. 2B? Yeah. Okay. Yeah, 2B, I know, but If you reference the index, it would be just what? 1, 1, 1?
1,
1, 1, okay. So 2b. So 1, 1. And so your question that will prompt on the user will be like either say, enter a price or enter a seat number. Okay? And you have to make that choice. If it's 1 for price, 2 for seat number. If it's 2, then okay, what is seat number? And you have to tell the user to what numbers are they, like rows and columns. So you know what to enter. If I enter 1, 1, then okay, that's row 1, column 1. Okay. And so if that's a row 1, column 1, then you need to check if this row 1, column 1, this slot is 0 or not, right? If it's 0, then oh, sorry, the seat is taken. Pick another seat. Okay. So you have those two options here. So same thing. You can check that position. If that is a 0, then you can say it's taken. Otherwise, if it's not 0, then you make that 0, right? And that seat's available. So how do you know the 0? Yeah, how do you know what seat what seat are they looking for? Okay, so it's not really the way I have it here. Because what seat number I give you will be like, I want a seat at maybe like row 1 again, right? Row 1, column 1. That's my seat number, for example. So it's a list of 1 and 1, rows and columns. So if you kind of like test there. Okay, so I'll let you figure that out, right? I mean, so basically, this is actually, if you pick a seat number, it's actually easier because you don't really do any loops here. Okay, because I just give you the row number already. So you just check if if the row and number. So when you read it, you say something like this, right? I can do seat. Maybe initially you have like input, enter, seat number, and then just put rows and columns. And if you want, if you just do that, it's going to have a string, right? It's a string. If I enter 1, 1, then C will actually have a 1, 1 like that. And if this is much harder, it's doable. It's much harder because what if I have like seat 1, row 12? How do I know which is which? Is it row 11, seat 2, or is it row 1, seat 12? So it's much harder this way. So if that's the case, just put here, enter the row and then the column. Or you can say enter seat number, the row followed by space, and then the column, like that, okay? It's a rule, right? You give the rule. And then once you read it, if you do it this way, then you can convert this into a list, right? Convert to a list, and then you remove all the white space. So I'll let you play with this. Or if it's easier, just say, the row is equal to the input. Maybe just do that first, make sure it works. Insert the row number, and they have another one here for the column. Okay, so do that first until you kind of like get the hang of it, and then you can go ahead and then be a little more creative. So once you do that, it's pretty easy. You don't have to do any loop because, well, you have to assume that we don't have to check for like out of bounds indexes like that, assuming that the numbers are within the list. If I put like, okay, row 5, column 2, well, I only have like 3 rows. Right? So make sure that the maximum, minimum And then when you do that, is basically you just check this part here, right? So if the row at column is 0, then you put a message saying, sorry, it's taken, try again, right? And you loop back to the loop and then try again, else, then you just basically assign that, make that a 0. And then for that, make that a 0, and then it's taken, and then loops back again, and enter another seed or something. Okay, so that part is easier than checking if the seed is taken or not, and based on the price. Because the price you don't know, you have to check in there, right? All right, so that's part is. I hope that's clear. Just make sure we loop. It's going to be usually always you have 2 loops. Okay, it's just a very common algorithm. One thing that I didn't get to do is that the list, because list is so fun because you can do a lot of stuff with it. It's very easy. If I have a list, say that, let's do here, A is 1, 2, 3, right? And then B is 6, 7, 8. Oops. Okay, so 6, 7, 8. If I do C is equal to A plus B. Okay. You see that C now has both lists added together. The values are stripped off or extracted, and combines all the values into a single list and put into C. If you just add them like that, it's really, really useful for combining a list this way. Again, this is just shortcut in list. If I were to ask you to do this in using code without using the shortcut, you have to loop through A and then add that to B, or you can do append to B to A, right? So you can do that. You can add list doing this way. And also, do you remember we did the A is still 1, 2, 3, but do you remember we did like A times 3, right? It multiplies that, and it does it 3 times. Okay, I mean it didn't change the original value, of course, but it will multiply whatever your list have, and then you can set that to another variable. Let's just say we call it D is equal to A times 3, and now D contains the list that it's been duplicated 3 times of list A. It gets 3 times and adds each element into the list. So very, very handy, very powerful that way. And if you do like D a minus 1 here, so usually minus negative index is not allowed in some languages. Python, you can put a minus 1 here. What do you think that's going to happen? So you get a value of 3. Where's that 3 coming from? Okay. So if you, if you do a negative, do you remember we did the loop for in something range -1 or negative direction? Same idea here. You're going to start, instead of from the front of the list, you start from the end of the list to going backwards. So if you put a D of minus 4, you get 3 again, but this is like -1, -2, -3, -4. Go in the other direction. So if I do like -4 that way, if I do 0, 1, 2, 3, 4, 5. So if I say D of 5 equals D of -4, and the answer is yeah, it's true, right? Because I'm going the same direction, different direction, but it's the same value. So it's very flexible that way for Python. In some languages you can do that. I think JavaScript also allows it. PHP too. So pretty cool. So that means strings, you can also do the same thing, right? Go the other direction as well. All right, what else we need to do here? Now, do you have your book with you? Anybody read the books? No, I mean like the actual book. No, okay. Because I'm kind of curious. One of the students showed me his book, and at the end of the chapter, if you have the online version, it gives you those practice exercises and those programming exercises. So I don't know if the book has them or not. The book that student has didn't have those in this. I'm kind of curious why I didn't have it, or unless yeah, usually at the end of the chapter it has those program exercises, right? And his book didn't have it. I was like, whoa, really? That's weird. Unless he has a different version, I guess, but I didn't see that, so I just want to make sure it's not the case. Because there's a really good practice exercise in the back of the book. Let's see. Oh yeah, so when you print two-dimensional arrays or lists like this, notice it's very common to print, row and row first and then column. Okay, you can also print column-wise, right? Print column-wise and not row-wise. Okay, and you can do that too, right? So if I ask you to print this table here in column-wise, column first and not row first, how would you do it? It's just a matter of what should come first.
Would you swap the J and the I in the if numbers I and J?
Yeah, something like that, right? You swap the J and the I position. So instead of this one first, on the second, you put that up. You put that first. Okay. Because you're gonna do every column. And you print that first. I think that's how you do it. For example, if I go, yeah, so those are also you can do that too. So you're not limited to just print row-wise. So if you put back here, I have to comment these out. Let's remove the break here. I'm going to print everything here. So you print column-wise. Here I'm limiting my range because I'm using row-wise. I say length of numbers. And then, so I'm forcing my I to be the row and my J is the column. So if you want to print column first instead of row, then so that means these two numbers have to be swapped, right? You basically just swap the J and the I think. Because now I'll print the J first. Let's see, is that right? No, it's not right. It's gonna clash. So this is the number of rows, number of columns. You want to print the column first. So I think this would be like got me here. If I just swap the two, it's not going to work because these two will be out of range. I don't have that many columns and that many rows. So it's these values up here is going to be changed. and it gets tricky. See, for even number, I guess, let's see, put 9 here, back to what it was before. If I do that, I'm going to print like 1, 3, 2, 3, 10 first, and then next one. Now I want to print like 1, 4, 7, and then 2, 0, 8, 3, 6, 9, right, column-wise, and not row-wise. So row 0, column 1, and then I'll print row 1, column 1, row 2, column 1, like that, right? Then move to row 0 again, column 2, row 1, column 2, and row 3, row 2, column 2. So it's a little bit tricky here. I mean, if it's a perfect score like that, then I think all you do is you're going to say, I'm going to choose one row here, and I'll use this as the this will be like the J, and then the I will be just for the length of that entire column here. So if I do this way, because the J is going to start at 0, and I have 4 of them, 1, 2, 3, 4, so at 0 position. So J is at 0, but I starts at 0, so it's going to print 0 or 0, so you're going to get 1. But now I'm removing, increasing I instead of J. So I will be now 1, and J will still be 0, right? So for J is still 0. I did not change J yet. J was initially 0, but my I increases first. So my row will increase first, and then once I print all those numbers, it jumps to J, and now J goes to 1. So now J goes to 1, and then my I starts over again from 0 to 2 again. So it'll be 1 of 1, 1 of 2 of 1, 2 of 2. And if you print that out, you get, I didn't put that end thing here, but you see that the number is now printed in column-wise. Okay, let's do that again. So it prints 1, 4, 7, 2, 0, 8, and 3, 6, 9 that way. Just by swapping the variable here, because I call that here. So the row can be changed. It has to be the same, 0, 1, 2, and 3, and 0, 1, 2. But the J is, every loop through the row, the J stays fixed until I do the whole row first, for the first column, and then you increase the next column, and you do the row again. The next column, you increase the row again. Next column, row again. Okay, so just by swapping those two here makes that a different output. But you have to be careful here, because this one here, again, if I were to do something like that, then it doesn't work, because, you know, when I get here, J has only 3 here, but I said I want the first one, which is 4. So you're going to have an error again. So you have to do something here. That means before you do this one here, you have to check what the length is for that particular row. But that's another thing that you can think about. What if I ask you to print diagonally, right? Print all the diagonal numbers, you know. So something like that, it's, you know, kind of hurt your brain a little bit, but I want to print like from the bottom to the top, or the top to bottom, either direction. If I do like diagonally from 1 and then 2, 4, or 3, 0, 7, and this way. If I ask you to print like those, right? What?
Increment, maybe?
Yes.
I?
Yeah, something like that, right? Because for the first one, then there's no diagonal number, so it would be just 0, 0. The next value, okay, it has one row, so therefore I'm going to say one column, one row, and then you would increment I or j, whichever it is. The next one, it increases that as well. Right? So it goes like that. And then shrinks back down again like a sine wave. So those are little things that can get you, but crucial in certain areas, especially in data science. Okay, really useful. Okay, and then one more is when you want to search if an item or number is in the list. We did already here, right? We calculated by going, we loop through the range of every column, every row, and every element. We compare, see if that item is matched to a certain value. We did that. And if I want to check if a number or item is in the list, again, there's a shortcut. There's always a shortcut in Python. So let's say I have a list of A, has value 1, 3, 5, 10. Okay. If you want to check if a certain value is in there, you can use the for, not for, we can use the if statements. You say, if the number 1 is in if 1 is in A, we can do like if 1 in A. Okay, you see that it returns true, right? I check is there value 1 inside A or not? Yeah, that's true. If I do 2 in A, yeah, I get a false because it's not in there. So you can easily check for that. When you write a code, you do something like this. If the number 1 is in the list of A, and return, and then do something, right? And print yes. Else? Nope. Like that. And let's say A is equal to, again, 1, 3, 5, whatever it is. Okay. So if I run that, and let me turn all these off here. So that list there, if I run it, it will say yes, because 1 is inside the list. So this is really helpful. It's very, again, it's very easy because the search is already done. Otherwise, you have to ask you to search, okay, compare, loop the entire list of A, and then compare 1 with every element. If 1 occurs in there at least once, then just say yes. Otherwise, no, right? And it doesn't have to do with just numbers. You can also do with words and other objects as well. So really, really useful. What about the numbers up here? There's numbers here. What if I do something like that? Can I do something like that? I'm going to turn this off here, in not A, but in number. If I put 1 in numbers, and the numbers we had was these numbers right here. And if you run it, so 1 is not in there. Well, I see a 10. What about 10? Is 10 in there or not? It's not there. Is 10 up there? Yeah, it didn't work this one. Because number is a list of data. But if I do like a numbers of row 0, then returns true, right? So it doesn't do the whole thing, but it will do one row at a time. And so before you you look for a seat in that table, you can check every row. is the price of 3 is in row 1, row 2, or row 3. If it's yes, then go find it. Well, how do you find it? Well, you can also get the index number out of that too. See, right? And you can say, for example, again, if I do this data here, data has 1, 2, and 3. I want the index of the value of 2. Then you can say data index of the value 2. It returns you the index position of that value. Isn't it cool? And if you do like index of the value of 20, if it's not there, you say it's not in the list. You get an error. So you can say, okay, it gives a lot of ideas now. So if my data, I use the A list here as 1, 2, 4, 6, 7, 0. I'll say if like let's just say 6 is in the list of A, if that is true, then print the index where 6 is located in the list. So print the A index of the value 6. And it should print 0, 1, 2, 3, 0, 1, 2, and 3. So you print 3. The third position is what the first occurrence of the 6 is. So you can say, okay, I'm looking for a price $13. Do you have it on your seating chart or not? So you go to every row, check, is 13 in this row? No. What next one? Yes. If it is, where is it? Oh, it's in row 3. Okay, well, row 3, column 2, change that to 0. It's taken. Right? So you can do that as well. So using these given built-in functions is really helpful in that case. It makes it really fast. Or, of course, you can loop through every thing. I mean, this, again, only done on your behalf, so you don't have to do it. Python does that. But you would do like we did earlier here. It's the same thing. You look at every range, every element, you check that, and you will track the index, the row, and column. This one here tells me the row, column too, because I can loop through every row and check if 6 is in there. It does the comparison automatically. And so I will skip this process here and just print that out. So I say for I in number, for j in that, if 6 is in that that row. Actually, I don't really care about that column, right? You just need the row. The column is given by the index. It will give you that. So just do one loop, and then for every row is 6 in that row. Yes, if it is, give me the index. So you get the column. Okay. So that also can be used, and it's and there actually there are more, but those are the ones that are mostly used in Python because they're really, really handy.